Welcome to another episode of our Tech Deep Dive podcast. Today, we're unraveling the fascinating world of byte matrix multiplication, a crucial operation in machine learning, and exploring some intriguing optimizations that can be made. Now, before we dive in, let's clarify that while this discussion is grounded in some serious technical work, we're keeping things light and accessible. So what's the buzz about byte matrix multiplication? Essentially, it's about multiplying a matrix of unsigned bytes with one of signed bytes. Sounds simple enough, right? But as it turns out, this not-so-simple operation can be optimized significantly, making it of great interest for those working in machine learning and linear algebra. To start off, there's this concept of the naive implementation. Picture this. You've got a method that goes through every single element in two matrices to compute the product. It's like checking each spot on your board game to see where the pieces belong, time-consuming, and, frankly, kind of boring. The naive approach sets everything to zero, then goes through tons of loops until it gets its answer. But, as you might expect, it isn't the fastest option out there. Here's something cool. In our exploration, we stumbled upon an Intel instruction called VPDPBUSD. This little gem isn't just a fancy abbreviation, it's engineered for just this kind of byte multiplication. Think of it as a turbocharger for your matrix operations. Instead of just chugging along, this instruction can multiply groups of adjacent pairs of 8-bit integers, do some clever summing, and deliver results more efficiently. The magic really lies in how it handles those pairs, potentially turning an arduous task into a swift operation. Now, what if I told you that a little dance move called transposition could speed things up even further? By rearranging the input data, we can line things up perfectly for our turbocharged instruction to work its magic. It's like organizing your spice rack by color and size instead of creating a chaotic heap, making it way easier to grab what you need. In our podcast today, let's also touch on some benchmarks that reveal just how effective these optimizations can be. When we ran some performance tests on different implementations, we found a noticeable difference in processing times. Almost a four-fold difference. I mean, who wouldn't want to reduce their computation time from a few 100,000 microseconds to just a fraction of that? But hey, here's the twist. While we were celebrating our optimizations, we couldn't help but notice that our layout method outperformed established libraries like Gemology and IntGem, which shows there's always room for innovation and improvement in this field. And before we wrap up, let's touch a bit on future possibilities. Imagine taking these optimizations, bundling them into libraries, and making them universally available for different architectures. The potential impact on machine learning, especially in a world currently grappling with vast amounts of data, is a sweet prospect to consider. All right, so what are the main takeaways from this journey into byte matrix multiplication? First off, while naive methods might be a good starting point, they're often not where the magic happens. Turbocharged instruction sets and clever data management can lead to significant speedups. And lastly, as the tech landscape evolves, so too should our methods. We must always look for those chances to innovate and improve. Thanks for tuning in today. If you have any questions or opinions about fast algorithms or want to dive deeper into byte matrix multiplication, we'd love to hear from you. Until next time, keep questioning, keep exploring, and let's see what fascinating tech breakthroughs await us.